5, 4, 3, 2, 1.
Right. Good day, ladies and gentlemen. So I'm Isaac Joy, part of Group 1, and this is a beautiful machine which we made for our ME2110 project. So the problem statement for this project requires us to create a machine which gathers shrubbery, retrieves the Holy Grail, defeats the Black Knight, and delivers the grenades. So how did our team go about doing this? But before we could look into that, as usual, as any Georgia Tech project would impose on us, we had several restrictions. The restrictions were as follows. Firstly, we had to keep this below a $100 budget. Secondly, our main sources of power for this machine can only be from 5 mouse straps, a single pneumatic tank, and 2 motors. Thirdly, this all needs to fit within a 12 by 18 by 24 box, and it all needs to be completed within 40 seconds. So these were the restrictions which were imposed upon us, and the problem statement was already defined by me. So let's see what our team did in going about in accomplishing this.
Okay, I'm Will from Group 1, and so I'll be talking about the mechanics of our robot and how we actually assembled it for this task. And so our base is built out 2x4s. 2x4s are cheap, heavy, and we can resaw them to make custom lumber for other components that we have to build. And so working from the front to back, we've got our arms that actually extend out. We use the pneumatic cylinder, which is just mounted up to the front with some screws, and it extends our arms out. Our arms have a knuckle in the middle made out of a hinge, and at the base also have some hinges. And our hinges are custom made from store-bought that we kind of modified to fit our needs and make them work. And so we're on our way back. The other important part is our motor itself. Our motor is attached with hose clamps, and then we made a custom pulley to actually use string to retract our arms to collect the shrubbery. And our pulley, we were actually able to use our motor coupler from the elevator and make some modifications to pull the string back. And overall, cheap, effective, low profile, with the intentions of not having to rebuild a new machine for every single event from here on out. We have kind of a baseline and we can keep going. And hopefully we'll be successful in retrieving our shrubbery. And that's about it for the mechanics of this part.
Hello, I'm Daniel from Group 1, a computer science major at Georgia Tech, and I did the coding for this. So the way it works is once the banana plugs are touched together, it triggers a 38-second loop, which is basically a fail-safe, so we have 2 extra seconds where the machine will stop moving before the DQ time. And as soon as the banana plugs are touched together, the pneumatic cylinder is extended, and these will come out where they'll rest for about 3 seconds before the motor turns on and pulls in the wire for about 10 seconds. But what happens is the wire is going to wind up, so we need some way to unwind it. And to do that either requires to unscrew the motor and to unwind it manually, or we've included a button into the assembly which works in the banana plug loop where we can actually unwind it using the code, which will save time during setup, which could prevent DQs. Also, a lot of this was done in advance in SolidWorks, and we have models in there for the basic premise of the idea, as well as like rough lengths for the arm segments, and it just gives us a better idea of relative dimensions of the entire arena and objectives. And these will be included at the end.
Hey guys, Isaac again, and as you heard from Will and Daniel before, they spoke to you about the mechanics and coding of this beautiful machine out here, and we feel that it's a really structurally sound, robust, and lightweight machine which can do its job in a cheap and effective manner. So that's it for us, that's our presentation. We are a 3-man group. However, to come to power with the rest, we've made ourselves a 4th member.